Science Academy, the science provider of the nation.
Hi everyone, today we are going to study about quantification of elements and compounds. So the term quantification means we are going to calculate or count the values. So we have studied the structural unit of matter as atom. So atom is a very tiny particle. So we studied about elements starting from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. In these elements, we studied their atomic number as well their mass numbers. So atomic number is the number of protons of an atom of an element. Also the atom mass number is the sum of number of protons and neutrons of an atom of an element. So we studied how much for hydrogen. The atomic number is 1, helium 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. When we come to the unit of quantification, here what we do is we are going to calculate the number of atoms. But it is a really hard task because atoms are invisible to the naked eye. As it is invisible to the naked eye, it is not possible to count them. It is not possible to count them in the viable method. Therefore, we use several techniques. To identify, to understand those techniques, we will be studying some terms in this unit. The first term what we study is atomic mass. And the second one what we study is atomic mass unit. Thirdly, we study about relative atomic mass. And fourth, we study relative molecular mass. And then we will be introduced to a term called mole. And then finally, we will study regarding the term molar mass. If we are capable to understand and if we can communicate the relationship between them, we will be able to go clearly throughout this subject. So we will start from one by one. First, what is atomic mass? Atomic mass. Atomic mass is the mass of an atom of an element. For example, we know that carbon is an element. Carbon has 6 protons, 6 neutrons and 6 electrons. This is the typical format of carbon. Carbon has an isotope as well. Carbon has 6 protons, 6 neutrons and 6 electrons. But we know that this is a very tiny particle. If you consider about 1 carbon, it is very much small. If I say you the atomic mass of carbon, the answer will be, if I say the atomic mass of carbon, the answer will be 1.993 into 10 to the power of minus 21. 1.993 into 10 to the power of minus 21 gram. Minus 23 gram. Minus 23 gram. So, once you get this index, you don't think that it is a large value. You know, here it is minus. If it is minus, it's going to be 0.00020 continuous zeros and then 1993 grams. So it is a very small value. If we consider the atomic mass of sodium, it is 3.819 into 10 to the power of minus 23 gram. And if you consider about chlorine, It is 5.903 10 to the power of minus 23 gram. Now the issue what we have is these atomic mass values are very small and complex numbers. If you consider these numbers, they are really complex values. So first, what is atomic mass? Atomic mass is the mass of an atom of an element. A very simple task. So here the problem, if we use this value to do calculation and quantification, so if I ask you, if one carbon is 1.993 in 10 to the power of minus 23, what is the mass of 10 carbon? You can immediately say that 1.993 in 10 to the power of minus 22. This is not an issue. But the case in calculation, when we come to the calculation, chemical calculation part, it is really hard to get these values. It is really hard to use this value, these masses to the calculation. So we introduce a new method to quantify the atoms of elements. Let's see how we do it. So we studied that atomic masses are complex values. We need to make these complex values into simple form. How we can make it into simple form? Let's come to the point. If I give you numbers such 55, 44, 110 and 1100, these are bit complex values. If I ask you to make these four values into simple format, what you can do is you can select a large common factor of them. Large common factor, highest common factor of them. So what is the highest common factor you can take? It is simply 11. If you divide by 11 all this number, it will be a very small number. So here it will be about 5, 4, 10, 100. Now these values are less complex than these values. Such, when the atomic masses are complex values, we need to make it into simple form. So what we do is, we divide the atomic masses by atomic mass unit to obtain the relative atomic mass. So the atomic mass divided by atomic mass unit, it gives the relative atomic mass. So if you consider this atomic mass is a complex value, atomic mass unit is the largest common factor or highest common factor, we divide it, and the relative atomic mass is the simplest form. So there was a huge competition to identify what is this atomic mass unit, because it should capable to make all the or most of the atomic masses into simple format. So I gave you complex numbers. For example, the mass of carbon, atomic mass of carbon is 1.993 into 10 to the power of minus 23 grams. If you think about sodium, it is sodium. If you think about sodium, it was 3.819 into 10 to the power of minus 23 gram. Again a complex value. So while identifying the complex value, the highest common factor, you might think why it can be 2, 3. It is not easy to identify. So they went through several processes and identified the atomic mass unit as 1/12 mass of carbon 12 atomic mass. How they obtain it? Carbon 12, the isotope carbon 12, atomic mass 1/12. So what is the large common factor, highest common factor they identified was carbon 12 atomic mass 1/12. That means you have to take the 1/12 part of carbon 12 mass. Got the idea? So it is a very simple thing what they did. So people or scientists define the atomic mass unit scientists define the atomic mass unit as 1/12 of carbon 12 atomic mass. So the value of atomic mass unit was, the value was 112 multiplied by 1.993 into 10 to the power of minus 21 gram. So this value was obtained as 1.67 into 10 to the power of minus 24 gram. So it is lesser than this. So this is the atomic mass unit value. But if they ask you what is atomic mass unit, you should say that 1/12 of carbon 12's atomic mass. The definition of atomic mass unit is as below. The mass of the unit relative to which the masses of other atoms are expressed is called the atomic mass unit. The mass of the unit, so I explained you in the previous case why we are taking this atomic mass unit. We are taking this atomic mass unit to take the relative atomic masses of atoms. Because the atomic masses are really complex, you need to take a relative atomic mass. So we need to divide it by a large common factor. That specific large common factor is the atomic mass unit. So they calculated it as 1/12 of carbon 12 mass. So here the definition clearly says you that the mass of the unit relative to which the masses of the other atoms are expressed is called the atomic mass unit. If they ask you what is atomic mass unit, the answer should be this. But if they ask you the equation, you should give the equation that atomic mass unit is 1/12 of carbon 12 atomic mass. If they ask you the value, this should be the value. Next, we are going to study about relative atomic mass. So it is a very simple format. We studied that relative atomic mass I symbolize as RAM. It is equal to atomic mass divided by atomic mass unit. Also it can be written as, if you substitute atomic mass unit, atomic mass divided by 1/12 of carbon 12 atomic mass. If you notice a point, atomic mass unit has the unit gram. The unit of atomic mass unit is gram. Even the unit of atomic mass is gram. Therefore, relative atomic mass has no unit. It has no unit. Relative atomic mass has no unit. So, these relative atomic mass units the relative atomic masses are calculated and given to you. It is in their textbook, in your textbook, but it is not compulsory to by heart them. Usually in papers they used to give those values. Those values are as below. Hydrogen, the relative atomic mass is 1, helium 4, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20, sodium 23, magnesium 24, aluminium 27, silicon 28, phosphorus 31 and sulfur 32, chlorine 35.5, argon 40, potassium 39 and then calcium again 40. So relative atomic mass has no unit. Relative atomic mass can be obtained by dividing the atomic mass by atomic mass unit. For example, if they ask you a question like this, they will ask you a question like this: the atomic mass of sodium is 3. The atomic mass of sodium is 3.819 into 10 to the power of minus 23. Okay, atomic mass of sodium is 3.819 10 to the power of minus 23. The atomic mass of carbon is 1.998 into 10 to the power of minus 23. Find the relative atomic mass of sodium. They might ask you a question like that. Therefore, you have to go to the answer in this format: relative atomic mass of sodium is equal to atomic mass of sodium divided by 1 into 12, 1 over 12 into 1 over 12 into atomic mass of carbon. Okay, so therefore the value will be as this: 3.819 into 10 to the power of minus 23 divided by grams divided by 112 into 1.998 into 10 to the power of minus 23. So the gram and gram get cancelled and the value will be, as given in the book, the value will be 23. So here is a very simple part. Try to combine everything and study, starting from atomic mass, complex numbers. Therefore what we did, we introduced the term atomic mass unit, and now we have found something else called relative atomic mass, which has no unit, is relative molecular mass. So relative molecular mass is a very simple thing. Relative molecular mass is derived from the equation that understand the term molecular mass of the molecule. For example, calcium is an atom, but if you think of calcium carbonate, it is a molecule. So mass of this molecule divided by atomic mass unit, that is relative molecular mass. But when we come to the calculation, typical calculation in our setup, we are not using this method. What we used to do is, for example, if they give you the atomic mass of calcium is 40, the atomic mass of carbon is 12, the atomic mass of oxygen is 16, and then if they ask you the molecular mass of calcium carbonate, the answer can be obtained in this manner. The mass of calcium is 40, the mass of carbon is 12. Sorry, the relative atomic mass of carbon is 12. The relative atomic mass of oxygen is 16, but there are 3 oxygens present in, therefore 16 into 3. So the value will be 40 plus 12 plus 48. The answer will be 100. No unit, the value will be 100. If you think about sodium chloride, how many sodiums are there? One sodium is there. How many chlorine? And one chlorine is there. So therefore sodium is 23, will be get this data, and chlorine is 35.5. Yeah, the value will be 35.5. So how we can go to the answer is a very simple manner. One sodium is there, therefore 23, plus one chlorine is there, therefore 35.5. So here the answer will be 58.5. Next one. Let's consider the molecule calcium phosphate. It is Ca3PO4 twice. Now it is a challenging task for you all. Say me, how many calciums are there? Ca3, 3 calciums. How many phosphorus are there? 1 or 2? There are 2 phosphorus. And how many oxygens are there? There are 8 oxygens. Therefore, the value should be the calcium. Calcium is 40 and phosphorus is 31. Oxygen is 16. So therefore, 3 into calcium 340 plus 2 into phosphorus is 31 plus 8 into 16. Correct? So here it is 120 plus 62 plus 8 into 16, it is 66, 128. So 248, and then it is 310 if I am correct. So 120 plus 62 plus 128, 248, 248 plus 62, it is the answer will be 310. So there are some questions in your exercise book, you can start them to do, and in the next lecture we will be studying about the term mole. Okay, thank you.
Science Academy, the science provider of the nation.